Bismillahirrahmanirrahim. Assalamu alaikum dear students, welcome back in lecture 02 part example 01 part C1. We have started this design example in E01A. We have covered some portion of this example in this lecture, while this case 1 we have covered in E01 part B, while this part, which is case 3, which is case 2, we will cover this in the E01C1, C1, C2 and C3, because in this part C1, C2, C3 we will cover various ACI methods, as we discussed, if you remember, in part lecture 02 part 11 or 12, I think so. We have covered different methods of ACI, that is, we have direct method, we have graphical method, we have trial and error method, and we have approximate method. We have different design tables. So we will use in the different design tables and we will design. So all these methods is for determination of area of steel. So in today's lecture we will cover this first one, that is direct method. So let me discuss this method, that is the direct method. So in direct method we have two methods. We will use the equation, area of steel equation, which is the most simplest one, 0.85 fc prime divided by fy into b to d minus square root d square minus mu divided by 0.3825 fc prime into b, bracket close. Now we know all the values. We know the B value. The B value is 12 inches. We know the D value now. In case 2, let me write down this. In case 2, it will given to us that use H equals to the overall depth equals to 30 inches. So let's say we are assuming two layer of reinforcement. So in that case the D value will be H minus 75 mm. I have already discussed this in previous parts. 75 mm is equal to 3 inches. So that why my D will be, effective depth will be H minus 3, and 30 minus 3 equals to 27 inches. So this is now my desired effective depth, while in the previous case 1 we see this is 24 inches. We will use this one. Now, so we know about the B value, the D value, and we also find out in part A, we find out the mu value. Mu value is 352.4 kf feet, right? This is kf feet, so it must be multiplied by 12 to convert it into inches. We know about fc prime, which is 3 ksi, and we know about the fy value, that is 60 ksi. So all values in hand, so we will plug all the value and we will calculate the value of area of steel. So let me plug all the value. We have to multiply it with 12 divided by 0.3825 multiplied by fc prime, which is 3 ksi into 12. Here I am using ksi, and therefore here, because I am using kf inches, so that why unit must be consistent. Now we can plug all these values in calculator and we got 3.294 square inches, which is my desired area of steel. So this is from this equation, right? The another method or the another formula which is also in direct method is, let me calculate the value of omega. We know omega, so 0.85 fc prime is 3 divided by 60. I have got the value of 0.425. This is omega, and from this I will calculate the value of R, which is mu divided by bd square, the value into pounds, so multiplied it by 1000. We got the value which is 484 psi, right? The value of R is in psi. Now we will calculate the area, bracket close. Now we know all the values, and which is 3000 psi, right? Because this value is in psi, this value, sorry, is in psi, so that why I'm using 3000 psi and under square root bracket close. So if we use your calculator, you got the value from this 0.0102, which is greater than rho minimum. We have already calculated rho minimum in part 1a. We have already calculated this rho minimum value. This is 0.0033. In part 1a we calculate this one, right? So this is my rho value, and I will calculate the area of steel, which is A is, it is rho BD. So we know the value of rho, which is 0.0102. we have already calculated 27. We got the value of 3.31 square inches. So this is all about the direct method. We have seen this value which is close to this value, right? 3.3, which is close to 3.3, and here we got 3.31. so all the values are close. So you can use either this equation. I recommend always to use this equation, right? Because this is the easy one equation and you don't need to calculate R, omega. This is the most simple equation and you can use this one. For this area of steel, which is 3.331, we can cover this area of steel by using 6 number 7 bar. By using 6 number 7 bar, it gives us 3.6 square inches, right? So this is my final selection of bar. You people can use the different selection. You can either use number 6 bar, right? Number 6 bar area will be calculated, right? Area of bar, which is 6 divided by 9 square. So area bar is 0.441 square inches. This is number 6 bar area. Now if you are interested to find that how much number 6 bar will be needed, so number of bar 3.331 divided by 0.441, which is round about 7.50. If we round this So this is 8 number, 8 number of bars needed. So it is make sure that you will choose the close combination, right? Let's say here I'm using 6 number 7 bar, so the number 7 bar area will be number 7 bar area, 7 divided by 9 square, so which is 0.604. So number of bars 3.331 divided by 0.604. Here I got 5.48 number, which is rounded to 6 number. Remember, you can't select you can't choose 5 bars, right? So we have to add it with 1, so that's why I'm choosing 6 bar. So here this selection is also close, and here this selection is also close. So here I need 8 number 6 bar, 8 number 6 bar, and here I need 6 number 7 bar, right? If let's say if I'm using number 8 bar, let's say if I'm using number 8 bar, so the number of bar will be 3.31. The number 8 bar area is 0.79, right? 8 divided by 9 square, 0.79. so that's why so this time I got 4.18. Now if I round this to 5, so here because this will give me, if I am using 5 number 8 bar, so it will give me area of steel 5 times 0.79, it will give me 3.595. 5 number 8 bar, it will give me an area of steel is 3.95 square inches. And if I use 6 number 7 bar, it will give me an area of steel which equals to 3.6 square inches. And if I use number 6 bar, so 8 bar needed of number 6, so this will give me 8 times 0.441, it will give me 3.52. So I can select more option, right? I can choose number 9 bar, number 10 bar. So for number 9 bar, the area of number 9 bar is 1 square inches. So this time I need 4 bars. 4 number 9 will give me area of steel which is 4 square inches. And number 10 bar area, 10 divided by 9 equal square 1.23 square inches is the area of number 10 bar. If I divide 3.31 divided by number of bar area, this time it will give me 3 number 10 bar will give me an area of steel which is 3 times 1.23. it will give me, this time it will give me 3.69 square inches. So from all these options, the best one is this one, 3.52, and the second one is this one, right, which is close to 3.31, right? These two options are close to 3.31 square inches. So choose the closest one. but make sure that number 6 bar can be justified in the cross section, and it will pass the check that S provided should be greater than S minimum but should be less than S max. We will use this check in the last portion, that is in the last method, and you will see how to adjust. Either we can adjust number 7 bar or either we can adjust number 6 bar. Let's say if we are using 6 number 7 bar and we will calculate the spacing S. So this time S will be 12 minus 2 times 1.5 minus 2 times stirrup diameter minus we have 6 bars, so 6 number 7, so 7 divided by 8 divided by number of spacing, so number of spacing will be n minus 1. So I have 6 bars, so 6 minus 1, number of spacing will be 5. So that's why I have divided by 5. So the spacing will be this time so I got 0.6. Now 0.6 is if I compare this with minimum criteria, which is S minimum, which is the diameter of the bar, and diameter of the bar is 7 divided by 8, so I got 0.875. So this time we see here that S is not greater than S minimum, so not okay. We can't adjust the 6 number 7 bar in one layer, and we have to provide 6 number 7 bar in 2 layers, right? In 2 layers. So that's why I have to provide 3 bars in one layer. So the final arrangement will be this is 3 number 7 and this is also 3 number 7, right? So the the clear spacing will be this time is equals to 12, which is the width of the beam, 2 times side cover, which is 1.5, 2 times stirrup dia, which is 3 by 8, minus number of bars. This time we have 3 number of bars, 3 times diameter of the bar divided by number of spacing. So this time we have 2 spacing, 1 and 2. So this time I use my calculator. So this time my S will be 2.81, which is more than S minimum, which is number 7, or 0.85. So this time this spacing will be okay. And we already calculated S max, which is 10.31 inches. So my S provided is greater than S minimum but less than S max, so this arrangement is okay. And similarly we can provide here we can provide 8 number 6 bar. So if we provide 8 number 6 bar in 2 layers, so 4 number 6 bar. So this time it's 2 times stirrup dia
minus number of bar, which is 4, and the diameter of 6 number 8 bar will be 6 divided by 8 divided by the number of spacing. So this time we have 4 bars, so we have 3 spacing, 1 2 3. So we will divide this by 3 and we got, so this time the spacing is 1.75 inches, which is more than its minimum and less than its max. So this arrangement is also okay. But here, if you can see, here the clear spacing is 1.75, while here you can see the clear spacing is 2.81. So this one will be more preferable as compared to the lower one, but make sure that number 7 bar is really available in market, right? Because sometime it is not available, so that why in that case we prefer number 6 bar, right? So this is the selection, right? We have to find out different arrangement, we have to combine different number 6, number 7, number 6, number 5 bar, but make sure the design will be simple, the arrangement will be simple, and the bars are available. The placing of the bar will be simple, because if we choose different combination of bars, it is difficult on the site to provide and cast such those bars. So that why I always choose one size bar, right? We can choose two size bar as in previous part, which is in case 1 we choose different combination, right? We choose number 8, 3 number 8 and 3 number 7 bar in the previous case, but this time the best option is this one, right? Because this is close to the calculated value 3.31 square inches, and this option is the second best one. Always choose the closest one, because it due to larger size of area of steel, it causing it affecting the epsilon t value, right? It affecting the epsilon t value, and in that case our criteria, which is greater than 0.005, is unsatisfied, right? So that why, and similarly then p value will not remain as 0.9, because if epsilon t is not greater than 0.005, so then the p value will not be equal to 0.9, and we have to calculate it the p value. So that why always choose such bar area which is close to the calculated value, right? Thank you for watching. See you in next part.